Assalamualaikum and hi to everyone. We are Diploma of Science student AS120. Today we want to present about techniques of differentiation for our Calculus 1 project, code Mat 183, group course FMA ASMAT2. But before we move on to the main topic, let us introduce ourselves first. Hi, my name is Muhammad Dani Damian Mirusmadi. My student ID number is 2024492234.
Hi, my name is Muhammad Hanif Amsyah bin Hamri. My ID number is 2024629032.
Hello, my name is Muhammad Shafiq. My student ID is 20244X0092.
Hi, my name is Muhammad Amin Iskandar Bezohan and my student ID card number is 2024-855 and 816.
What is differentiation? Differentiation is a fundamental concept in calculus that involves finding derivative of a function. The derivative represents the rate at which a quantity changes. Now, let's look at the formula. This is called the first principle of differentiation. It gives the derivative as the limit of the average rate of change as the interval shrinks to zero. Now, let's find out what is techniques of differentiation. Techniques of differentiation is used to find derivatives quickly without using limits every time. Calculus provides several powerful rules and techniques. First, we have constant rules. Constant rules is when the derivation of a constant is always zero. Then, we have power rule. Power rule is used for any term with a variable raised to a power. If you see x to the power of n, just bring the power down in front and subtract 1 from the exponent. Next, we have polynomial rule, used to differentiate polynomial functions which are made up of sums or differences of power functions. To differentiate polynomial, apply the power rule to each term of a function, then keep constant with each term. Lastly, add or subtract the results term by term. Then we have sum and reference rule. We use this rule to differentiate each term separately. Product rule was used for the product of two functions. Then we have quotient rule. We use quotient rule for dividing one function by another. Other than all the rules I have stated so far, there are still more rules we can use. Let me show you. We also have derivative or trigonometric functions. Students need to memorize all the formula given for this function. For derivative of exponential functions, the derivation of e to the power of x is itself. It's the only function like this. Then we have derivatives of logarithmic function, which is the opposite of exponent. Lastly, we have chain rule. Chain rule is used when one function is inside another.
Okay, we will start the first question. The question is state, find derivative for following function. A, 3x squared second of x plus 2. To solve this, we need to use the product rule. The product rule states u prime v plus u v prime. Step 1, we need find the u and v. For u is 3x and v is second of x plus 2. For the u prime and v prime, u prime is 6x and v prime, we need to use the formula this. And we get the second of x plus 2, 10 of x plus 2. Step 2, now we applying the product rules, we get 6x second of x plus 2 plus 3x squared times second of x plus 2, 10 of x plus 2. We got the answer, this. For step 3, we can factor out the second of x plus 2 to simplify the further. We can load the our solution this, and we can also get the answer 3x second of x plus 2 plus x 10 of x plus 2. This is answer for question A. Now let's move on the second function. Function is 4x plus 2 over cos x. For this problem, we will use the quotient rules. The quotient rule states the derivative of u over v equal u prime v minus 2u v prime over v square. Step 1, we need to identify which one u and v. For the u is the 4x plus 2, and for the v is cos x. For the u prime, we got 4, and u prime, we got negative sin x. For the step 2, we applying the control rule, we got 4 cos x minus 2, 4x plus 2, negative sin x over cos x square. We get the answer this. Before that, we simply this we get 4 cos x plus 4x plus 2 sin x over cos square x. For the all this, we get the answer is secant x 4 plus 4x plus 2 10x.
Now we're gonna go to the third question, which is find the dx over dy by using implicit differentiation for y ln multiplied by 3x minus e power of 2x plus 1 minus tan multiplied by 4y equal to 0. First, we need to differentiate all the terms, which is y ln multiplied by 3x. We need to use the product rule to get the dy over dx ln multiplied by 3x plus y over x. And for the second terms, e power of 2x plus 1, we need to use the chain rule to get the 2e power of 2x plus 1. And for the third terms, we need to use the chain rule also. And for the tan, derivative is the secant square, and the function is 4y, so we get the 4 secant square multiplied by 4y dx over dy. Now we put all the terms together, we get the dy over dx ln multiplied by 3x plus 4 plus y over x minus 2e power of 2x plus 1 minus 4 secant square multiplied by 4y dx over dy equal to 0. And then we need to separate the dx over dy part the terms and another terms to this, and we will get like this. And to get the x over dy, we need to move this part into the another terms, and we will get the answer is dx over dy equal to 2e power of 2x plus 1 minus y over x over ln multiplied by 3x minus 4 secant square multiplied by 4y. And that's it from me.
First, we let fx equal to x square root 4 minus 2 over square root x. So we change it to x power of 1 over 4 minus 2x power of negative 1 over 2. So for f prime x is 1 over 4x power of negative 3 over 4 plus x power of negative 3 over 2. So the final for f prime x is 1 over 4x power of 3 over 4 plus 1 over x power of 3 over 2. For the x we got is 80.99, for x naught is 81. So the formula is delta x equal to x minus x naught. So the final result we just got is negative 0.01. For value of x, we put 81 is f81 equal to 81 power of 1 over 4 minus 2 multiply 81 power of negative 1 over 2. So we got is 2.778. For f prime 81 is 1 over 4 multiplied by 81 power of 3 over 4 plus 1 over 81 power of 3 over 2. So the final answer is 0.012. For the formula we use is f multiplied by x naught plus delta x equal to f x naught plus f prime x naught multiplied by delta x. So we just put the value in the formula, and the final answer we got is 2.778. That's all.
To conclude, in this assessment, we focus on techniques of differentiation. Based on the 4 questions given, we can learn about the meaning and techniques of differentiation that we can use to solve in our daily problems, ability to compute derivatives using explicit and implicit methods, and skill in applying linear approximation for estimation.